So this is a quick lesson about solving systems of linear equations. If you are given this system right here, 3x minus y plus 4z is equal to 6, y plus 8z is equal to 0, and negative 2x plus y is equal to negative 4. You can choose to use the elementary row operations, or as the book calls them, elementary operations. Or you could choose to use an augmented matrix. The advantage of using the augmented matrix is, of course, you don't need to write down the x's and the y's and the z's. You can just write all the coefficients. So I'm going to go ahead and use the matrix. So first row is going to look like this: 3, negative 1, 4, 6. The second row will be 0 because there are no x's. Y, z, answer. And in the last row, there are no z's, so negative 2, 1, 0, and negative 4. So once you set up your augmented matrix, you can then use the elementary row operations. So we want to, of course, have a 1 in this slot right here, 0 is underneath, a 1 in this slot, 0 underneath, and a 1 in this slot to get it into row echelon form. And if you want to get into reduced row echelon form, then you also need zeros here and here and here. So you can decide which way you want to do that. So either reduced row echelon form or just row echelon form, and then do your back substitution. So you can continue to use this as a 3 if you want to, but I think the first row operation should be making that a 1. So dividing everything here by 3. So negative 1/3, 4/3, and 6 divided by 3 is 2. Leaving that second row the same, and third row the same. You can do as many row operations at a time as you want, but I think it's a good idea to do them one at a time and maybe identify what you did. And that way when you go back, you can see exactly which steps you are using and then in which order. So once this is a 1, we already have the 0 in that slot right there. We need to make this a 0 right here. So we're taking the first row times negative 2 and adding it to the third. So I'm going to try to do this without writing this down. So negative 2 plus 2 is going to be 0. We take 2 times negative 1/3, that'll be negative 2/3. Negative 2/3 plus 1 should give us a positive 1/3. 4/3 times 2 is 8/3. 8/3 plus 0, of course, will be 8/3. 2 times 2 is 4. 4 plus negative 4 is 0. So that's the new third row. So if you just change one row at a time, it's easy to recopy everything and make sure you're following the same order as the previous matrix. So the first 2 rows should remain the same. So now that you have a 0 here and here, this is already a 1. Good job. This needs to be a 0. So if you want to make this entry right here, so third row, second column is 0, you need to use that second row. So the first row is going to remain the same. The second row will remain the same. And now the third row, we want to make this a 0. So if we're going to use that second row, it looks like we need to multiply the second row by negative 1/3 and then add that to the third row. So I forgot to write this up here. You need to replace that row with either the constant multiple. You can do adding the rows together. You can also swap rows. So this one, we're just doing the constant multiple. Here we did a sum of 2 rows and replacing the third row in this case. So we need to do a negative 1/3. So negative 1/3 plus 1/3 will be 0. 8 times negative 1/3 is negative 8/3. Negative 8/3 plus 8/3 is also 0. So when we try to write this in terms of making this a 1, it's not happening. It's going to be a 0. So once you're looking at this matrix right here, you automatically know there will be an infinite number of solutions. That's because this row of zeros will indicate that there is some constant multiple happening here with our planes. So infinite number of solutions. So now if you want to go to reduced row echelon form, you can make this entry this entry right here a 0. Make this entry right here a 0 if you can. Looks like we're not going to be able to make this a 0, but we should be able to make this one a 0. If you don't want to do that, you can use this second row, and then z is going to be our parameter. So if you look at the first and second rows, remember the pivot column is the first entry that has the 1 in it. So the furthest left that we're going here, this will be x, this will be y. Remember this would have been z, but you see a 0 there instead. So z is going to be our parameter. So the second row says y plus 8z is equal to 0. We just solve that for y in terms of z, because z is going to be our selection. We're going to make it a 1 or a 2 or whatever number you need it to be. So here's the advantage of reduced row echelon form. If this was a 0, we can write x directly in terms of z, or we could just go ahead and write x minus 1/3 times y plus 4/3 times z is equal to 2, and then replace y with negative 8z. So you don't need reduced row echelon form if you don't want to write it that way. So I'm going to go ahead and replace that. So negative 1/3 is then multiplied by negative 8z. Because if z is the parameter, we want to write everything in terms of z. So x in terms of z and then y in terms of z. So it looks like we're going to get 8/3 plus 4/3. Sounds like 12/3. So x plus 4z is equal to 2. So solving for x in terms of z gives us the answer in terms of x. So if we write it as an ordered triple, there is what x is equal to. We know that y is negative 8z, and then z is our parameter. So if you remember how parameters work, if you give me a value for z, you can then figure out what x and y are in terms of z, and this should be a solution to the system. So if we go back to the original system, 200 should work in all 3 of the equations. So let's see if this actually does work. So 3 times 2 is 6, 0, 0, that does work. The middle row is 0 and 0, that's going to be equal to 0. And then the last row is negative 2 times 2 plus 0, which is also equal to negative 4. So this is just one of the many solutions for this system of equations. Now you can use any parameter that you want here. So if your row of 0 happens here, and if you also have a 1 in this slot and a 1 in this slot, it makes sense to use z as the parameter. If you had a 1 in this slot, and this row was all zeros, it would make sense to use y as the parameter. So the choice of parameter is independent of the actual solution. You're looking here at writing it in terms of z.